Oh, I can't hear you.
You can't hear me.
Oh,
Okay.
maybe it's my problem. Wait a sec.
Oh, the others can hear me, it seems. All right, let's give it a few more minutes for people to join. Where's everyone joining in from today? If you can let me know where you're joining from and also what your Web3 experience is as a developer. All right. Got somebody who knows how to implement an ERC20 contract, someone who's a beginner with experience in Web 2. And has anyone here heard of Secret Network, or has anyone here worked with contracts on the Cosmos? I'm also curious about that. Or is everybody here an EVM developer? Welcome everybody who just joined. I was just asking what your Web3 experience is and where you're joining from. If you can just post in the chat. That'll help me just in how I do this workshop. Okay, we got somebody who's heard about Cosmos but never worked with it. Lots of beginners, cool. What I'm going to show you guys how to do today is should be easy to implement, but I'll walk you through it step by step. And Dasha, you just let me know when you want us to start.
Yeah, actually, we can start. We can start by a brief introduction. So you can tell us your experience, what you're doing now, your projects, and when we can start the workshop.
Awesome. Well, hello everybody. Thanks for being here. My name is Conrad. I am a developer. I work for Secret Network Foundation, and I'm very excited to be here and also just to tell you about my journey becoming a Web3 developer. I started sort of like with an organization similar to Guide DAO, with just learning as much as I possibly could about Web3. So to anyone who's here, who's new, who's a beginner, I just want you to know you can do it. All it takes is just perseverance and just staying excited and being around dev communities that excite you. So just a little bit on my background is I'm a self-taught developer. Basically, during the time of like COVID, I just started teaching myself JavaScript, and it was also that I could join a company called ChainShot, which later became Alchemy University. So like another educating Web3 platform. But in order to take part in their platform, you had to learn JavaScript so that they could teach you Solidity, which maybe is part of what your journey has been as Web3 developers in the EVM ecosystem. But so I had an amazing experience doing that, beginning to become a Solidity novice. And then I went to my first ever hackathon in the summer of 2022 at ETH, New York. I'm based in New York City. And there, my team and we won like a small hackathon prize for our project. We made a music streaming dApp on the EVM. And then we entered another hackathon together where we won another prize. And I basically just got the bug. It was just the excitement of being around other EVM developers and just being in this space that was so new and moving so quickly. And from there, I basically just started to like be more and more interested in privacy tech, because all the interactions that happen on like the EVM on Ethereum, everything is public, and I started diving into ZKs, and from what I was seeing, it just seemed like it wasn't very user friendly, and it was hard for me to imagine a world where Web 2 people, traditional people who aren't Web 3 degens, would actually use this tech. And so I started Googling, and that's how I basically just learned about Secret Network. And Secret Network is a layer 1 privacy chain on the Cosmos. So different from the EVM, but tangential. I like to think of us as like intergalactic neighbors. And so the amazing thing is that when I started building on Secret about a year and a half ago, the way my journey started with that again, I was a complete noob when I came to the community because everything that happens in the Cosmos is in Rust. And I had just learned Solidity and JavaScript. But I was like, all right, well, I guess I'm going to learn another language so I can learn how to build with this privacy tech. And I started by just attending the developer calls. We have developer calls every Monday at 12 p.m. Eastern time in our Discord. Anyone here is welcome to join. We want developers there of all levels. And I just kept asking new questions every Monday. And eventually I built my first dApp in the Secret ecosystem. And then from there, I was kind of off to the races. I started by just doing small things for the documentation for Secret because I'd just been reading the documentation every day. And so I started making little changes. And then eventually, over time, was taken on as the DevRel for Secret Network full time. So all that to say, wherever you're starting from, if you just have excitement and enthusiasm and you're just building every day, you can totally do whatever you want in this space. And I'm excited for everybody who's here. But what I'm really excited to showcase with you today is this EVM toolkit. Let me just share my screen really quickly. Because what's so incredible is that in the time since I've entered the Web3 space since like early 2022, the blockchains used to be siloed. They used to not be able to communicate with each other. But the whole promise of the Cosmos is this idea of a world where blockchains are interconnected and able to communicate with each other. So just let me know real quick in the chat if you're able to see my Google Chrome. You should see this Ethereum developer toolkit. I'll be monitoring the chat just to make sure. Are you guys able to see this? Can you just let me know if it's screen sharing? So what's so, hope somebody says no screen. Okay, 1 second. Let me just do my entire screen and see if that's better. Is everyone seeing that now? Awesome. Okay. So what is very exciting is that in the time since I started developing with Secret in the past 2 years, this promise of an inner blockchain world has come to fruition. And what I'm really excited to show you today is how you as an EVM developer can make use of Secret Network's smart contracts in order to have things like privacy and randomness on the EVM and the interchain. Basically, let me just actually go through this so you understand what exists here. In order to be able to use this, the first thing you need to know is that you don't need to be a Rust developer and you don't need to know anything about the Cosmos ecosystem. We've been designing this in a way so that people who are EVM devs that have never written a single line of Rust can work with these smart contracts and with this documentation in order to take their Solidity code to the next level. So there's 3 parts of this that I want to teach you about, just like kind of from a bird's eye view, give you an overview. And then we're going to look at one thing specifically, which is how to have access true randomness on the EVM from a secret smart contract. And I guess just a little bit before I dive into this, just to understand how like secret privacy is different than traditional, maybe what you're used to, like ZK privacy in the Ethereum ecosystem, is that everything that happens on Secret happens because of this thing. It's a technology called a trusted execution environment. And basically what it just means is that secret smart contracts act like a black box where anything that is inputted into that code, it remains private and no one can actually see what that information is on chain. It's all encrypted. And so the difference is just that you have tons of composability and flexibility with how you write smart contracts on secret network. It's basically like anything you would write on a public chain. You can write any kind of function imaginable, but everything just remains private on chain. And so what this EVM toolkit does is we found a way to make it so that Ethereum contracts can make use of secret smart contracts so that you can bring privacy to your applications. And the other use case we have is to be able to access true on-chain randomness, which we're going to look at today. So let me just link this for you guys really quickly because I want you to have this information long after we depart from this call. So there's three main parts to our EVM developer toolkit. The first is you might have heard of Axelar GMP. Let me know in the chat if anyone has heard of Axelar before, but Axelar is a bridge. It's a message passing platform that allows you to send tokens between different blockchain ecosystems. And something else you can do with Axelar is called general message passing, which means the ability to send like actual like function calls from a contract to contract. So what we show in our documentation here in this Axelar GMP section is how to send a string, any like an arbitrary string, any string you write from Polygon testnet to secret testnet, and then from secret testnet back to Polygon testnet. And this is just like very little to no Rust experience required. This just teaches you the basics using Axelar, and this is just one option you have for interchain messaging if you want to work with like a inter-blockchain ecosystem. The second piece of this is our shared cryptography, our shared secret cryptography docs, which includes this private voting developer tutorial. This teaches you how to use elliptic curve Diffie-Hellman cryptography in order to make use of secret contracts so that you can have privacy in any function or in any smart contract that you write. Basically, the way this works is that like we have a voting example, a private voting example. And what it does is you have a Solidity contract that's extremely basic. It's just you can make proposals and you can vote on those proposals. That's all the contract does. The only difference from a traditional voting contract on the EVM is that all the votes you make are stored on chain as encrypted votes. So nobody can access them. The only people that can access them are the ones who have linked that contract to one of our secret network contracts that's able to decrypt those votes. And so basically this tutorial just teaches you how to use this shared secret cryptography and secret network smart contracts to make it so that you can encrypt any data you store on chain. And the only way they can be decrypted is with secret contracts. So that's a really cool example as well. And then the third thing, which we're going to be looking at today, is on-chain randomness for the EVM, which is snakepath RNG. Let me just check out the doc or the Discord really quick, make sure there's no more questions. All right, looks like we're off to the races. So I'm just going to walk you through these docs. Hopefully this should take not that long. The goal for this is to make it as simple as possible. But let's just see how this goes. So, and then if there's any questions at the end, we will go through questions. So, yes. So snakepath is this bridging protocol that we built out for secret network and for EVM chains. And the way it works essentially is that there are gateway contracts on the EVM and on secret that are able to communicate with each other. And that happens through this elliptic curve Diffie-Hellman cryptography. And basically all that means is that the gateway contract on the EVM side generates a public and a private key, and the secret network contract generates a public and a private key. And using the public key of the EVM side and the private key, or the private key of the EVM side and the public key of the secret side, you're able to create something that's called a shared secret, so that only those contracts on either side of this bridge are able to talk to each other. using this shared secret to decrypt any sort of information that is passed to each other. Don't worry if that sounds confusing. You don't have to actually like understand how it works underneath the hood, because we have designed all of that. All you need to do is understand just like how to actually call and implement the smart contract, which I'm going to teach you today. ID. Let's just do that really quickly. That's another function in here. There's only 5 functions to this: request random, set gateway, this event listener, which is fulfill randomness, and deploy. This query function just allows you to actually like query what's happening on the secret network side. So what I'm doing right now is, because it seems like the relayer didn't pick this up, I'm just looking at what like the information actually returned is, so that we can actually relay the information ourselves for the sake of this tutorial. Because the idea is that this transaction happens as quickly as whatever the block time is on the EVM chain you're working with. But then it's just up to however you write the relayer to actually return the information. So like if our relayer fails, like the Python script that is written, we can just manually relay that information. But hopefully like you'd have a relayer that just does all this automatically for you, so you don't have to like do it by hand. Okay, let me just see what this says. So now we're actually querying the secret blockchain underneath the hood. Saying it wasn't picked up. All right. Well, that is strange. Because what's weird is if we do like task ID 10, okay. So traditionally, I'm going to look into why these transactions we just did aren't going through. It's weird because we're seeing it on chain. But what that means is that the relayer, we only have one relayer currently set up for this, for these docs. So it means that the relayer isn't actually pushing this through successfully. So that's something we have to figure out on our end so that this works for you guys, so that there's 0 issues. But what would normally be returned from this query is you would just get this this information that's all about like the transaction hash that you're actually sending, and then it would just return back your randomness bytes. I'm going to see if I can get this working while we're still on this call. I just messaged the dev who's the head dev, and I'm just like, hey, brother, restart your relayer. Let's see what he says. And then we'll try this again. But in the meantime, are there any questions about what I've just shown you guys? And let me pull up something else, because we also have this, we have a demo on mainnet. I'm just curious if the mainnet demo is working right now. Let's see. Give me 1 second. I'm just going to stop sharing my screen and then reshare my screen.